Welcome back. This is the review. You need to get a piece of paper and a pen, and you're going to need to have your periodic table out. Get rid of everything else. All right? Get rid of everything else. Now, on each slide coming up for a while, there's going to be two compounds. There's two questions for each. The first question is this an ionic compound or a molecular compound? Then you have to write the name of the formula. Sometimes they give you a formula, sometimes they give you a name. So you're going to have to write the name of the formulas, or you have to write the formula for the names. Now, this is going to be all mixed up. We're going to have simple ionic compounds, we're going to have polyatomic ions, we're going to have transitional metals, and we're also going to have some molecular compounds. This is a challenge. The truth is, if you want to learn, you have to write stuff down. You have to commit on paper, because the littlest of mistake makes it right or wrong, right? It'll make it wrong. You have to write it down. You have to feel the sting of getting it wrong. That will motivate you to try harder moving forward. Please do not do this without writing. That's a cheat. You'll always say, if it was a test, I would have definitely wrote trioxide instead of dioxide. No, you do it now. That will help you learn. So right now, paper, pen, and your reference table, and then get rid of everything else. Okay? Is it ionic or molecular? I'm going to give you the pep talk on every slide, and then the name of the formula. Here we go. We got question 1 and question 2. Let's look at question 1. The name of this stuff is silver iodide. Is it ionic or molecular? How do you figure that out? Is the first name a metal? If it's a metal, then it has to be ionic. What is silver? Silver is a metal. Now, if you didn't know that, you can look silver up. It's number 47. Here's silver on the periodic table in the middle. It's not a nonmetal, so it's a metal. What is the formula? For an ionic compound, you have to look up in the corner. Silver makes what kind of ions? It's a transitional metal. It doesn't get a Roman numeral. It only makes a +1. Iodine is number 53. It's in group 17. It makes a -1. +1, -1. What do you think the formula is? Write it down. Now, this next one, CRN, is a little trickier, right? What the heck is CR? We don't say that too much. Put your finger in the box. 24. Put your finger in the box, number 24. Not only is it a metal, it's a transitional metal. And not only is it a transitional metal, it makes multiple possible cations. So the name of this is going to have a Roman numeral. How do we figure out the Roman numeral? I'm going to write on this slide because I think this one requires a little bit of writing. This is going to be chromium. This is chromium, and chromium makes a positive ion. Now, it makes a +2 or a +3 or a +6. Which one? How do you know? Well, this is how you know. It's in a 1-to-1 ratio with nitrogen, and nitrogen has to be a -3. Nitrogen only makes a -3 anion. It's in group 15. It's got 5 electrons in the outer orbital. It gains 3 electrons, -3. It's in a 1-to-1 ratio, so -3 has to balance with the +3. And if it's chromium and it makes a +3 ion, that's going to make it chromium Roman numeral 3 nitride. The first one, of course, in a 1-to-1 ratio is AgI, silver iodide. They're both ionic, of course. Next, if I'm going too fast, hit pause. PCl5 and PCl3, 2 in a row. P, what the heck is P? P is element 15. See where it is? It's on top of the stairs. That makes it a nonmetal. If your first atom is a nonmetal, you're molecular. So both of these are molecular. You can write M or I, molecular ionic. What's the name? There's 1 phosphorus and 5 chlorine. So it's going to be the first name rule. If it's a single atom, just say the name of it. Phosphorus. How many chlorines? 5. How do we say 5? Penta. Phosphorus pentachloride. And the other one? 1 phosphorus again. Phosphorus trichloride. 2 molecular compounds. One is called phosphorus pentachloride. The other one is called phosphorus trichloride. 2 more coming up. Here we go. Dinitrogen monoxide, Well, this sounds like 2 nitrogens, 1 oxygen. Nitrogen is a nonmetal. Number 5 has to be molecular. Number 6, SC. Where the heck is SC? Element 21. It's the very first transitional metal. Metal. If it's a metal, it's got to be ionic. It's going to be bonded to phosphorus and oxygen? What the heck? Better check table E, because that's where PO4 is. PO4 is a polyatomic anion. So the formula, dinitrogen monoxide, 2 N's, 1 O, N2O, and it's molecular. This stuff here is called scandium phosphate, not phosphide, phosphate. We don't need a Roman numeral because it only makes one kind of ion, a positive 3. Positive 3 balances a negative 3. Of course, it's ionic. PtCl4. PT, platinum. Where the heck is platinum? Right in the middle of the table. Number 78, right next to gold. Precious metal. Platinum, is a Roman numeral one, right? Two kinds of ions. So how are we going to figure out what ion charge is it going to be? I got to draw again. We have -1 for chlorine, -1, we got another -1, and we got another -1. There are 4 chlorides. Each one of them is -1. They make 4 anions. There's only a single platinum. That means the platinum has to be the +4 ion, right? Because in order to make this a neutral compound, 1 platinum has to give away 4 electrons, and 4 chlorines pick them up and become 4 chlorides. So we need a Roman numeral. Platinum is the name of the metal. What's the Roman numeral? Roman numeral 4, chloride. On the other side, BRF. Br is a nonmetal. This is a molecular compound. Br is bromine, and then F is fluorine, but when it's the second name, we change to ID, so it's going to be bromine monofluoride. The first name doesn't need a prefix. The second name always gets a prefix. And so when I clear my drawings, clear all drawings, and X out of this, I can go ahead. We have platinum, Roman numeral 4 chloride. Of course, it's ionic, and bromine monofluoride. Some kids will write bromine fluoride. Gotta have a prefix in the second name. Gotta have a prefix. I'm having fun. I like this stuff. ASF3. AS, that's a tricky one, right? AS, it's on top of the stairs. See the black bar, the black staircase? Non-metal. When your first name's a non-metal, you're going to be molecular. How do we name molecular compounds? Well, if the first atom's single, you just say the name of it, arsenic. And how do we say 3 fluorines? Arsenic trifluoride. That was easy. Now, the next one is Al, aluminum. Aluminum's cool, but we got this CLO business. Let's go to table E and not guess. When I go to table E, CLO is right here, and that's called hypochlorite. So to name these, aluminum, it's in the middle of the table, isn't it? But it's not transitional in the sense that it makes more than 1 ion. It's just aluminum hypochlorite, and it's ionic, right? Aluminum hypochlorite, and the other one there, molecular, arsenic trifluoride. So we got ionic simple, ionic transitional, ionic polyatomic, and molecular. Molecular have no metals and no ions. The other ones all have ions. So there's 4 systems running at the same time. Makes you a little wacko, but it takes practice, but you get better at it. Okay, number 11, nickel. A lot of you kids spell nickel wrong. You make it N-I-C-K-L-E like it's a pickle. Pickle is K-L-E. Nickel, metal is E-L. Nickel, Roman numeral 3. What the heck's a Roman numeral mean? Well, I know what it means. Let's put our finger in the nickel box. Nickel is 28. Nickel can be a +2 or a +3. Guess which one it is here? Roman numeral 3, +3. So if we have nickel +3, I'm going to write this one out again because I like writing with this silly thing. Nickel, Ni, and what ion does it make? it makes the +3. And then the bromine's in group 17, and it's going to make a -1 ion, -1 anion. Crisscross. Nickel Roman numeral 3 is the +3 ion, then you crisscross. It's got to be ionic. Now, the other one, vanadium. Ooh, this is a cool one. 23. Vanadium. Vanadium V. V is a Roman numeral. That means here the vanadium is making what charge? Well, you put your finger in a box. There's a bunch of choices, but Roman numeral 5 means +5. And S, woo, look at that S. I'm getting better at this, is a -2. Vanadium is a metal. How'd you know that? Well, it's a transitional metal right in the middle of the table. It's not a non-metal. That means it's a metal. Both of these are going to be ionic. They're both made with metals and non-metals and ions. What is the formula? You just got to crisscross this. This is not hard. You know what I mean? It's not hard. You never did it before. You'd be like, oh, what the heck is a Roman numeral? Go slow. Put your finger in a box. The answers are right there. Roman numeral 3 means +3. Roman numeral 5 means +5. And you know the rest of this stuff. Look at this. NiBr3. Crisscross. And then what about this vanadium one? VS2S5. Does that make sense? Sure it does. You have two vanadiums. They're both +5. That's a +10 altogether. And the sulfurs are -2 each. You have 5 of them. 5 times -2 is -10. +10, -10, neutral. We have a neutral ionic compound, which is perfect. Always neutral. +3, 3 -1s, neutral. All right. I like saying this one, tantalum, right? It just sounds exotic and cool. Tantalum, number 74. It's a metal. And Si, oh, it is a tricky one. Where is Si? C, that means yes in Spanish. It also means silicon. Silicon. First one, tantalum. Tantalum is definitely what? Put your finger in a box. +5. If tantalum is +5, chlorine makes a -1 ion. Due to crisscross, we got an ionic compound with the formula that you can easily crisscross. Now, silicon is a non-metal. It's a metalloid, but it's on the non-metal side. It's a non-metal bonding to another non-metal. This is a molecular compound. Another name for silicon dioxide, which is what this is beach sand. So you go to the beach near the ocean. You put your toes in the sand. You have a Diet Coke in your hand. It's a beautiful day, right? Beautiful Day is a great song by U2. Silicon dioxide is molecular and tantalum chloride. Now, we don't need a Roman numeral for tantalum, even though it's transitional metal, because it only makes one kind of cation. So you don't have to tell me if it's tantalum, it's +5. You don't have to tell me Roman numeral 5. It is +5. It is Roman numeral 5. You don't say things twice. Say things once. Why say that again? That's talking heads. All right. Big one here. A lot of letters. Oh, my gosh. A lot of letters. Watch what happens, though. Na, that's a metal. Sodium is a metal. It's got to be an ion. So that means the rest of this gobbledygook here must be on table E, and it is. Look it up. HSO4 is a -1 anion, polyatomic. It's an ionic compound, sodium, and that one's called hydrogen sulfate. 17, if your first letter is N, that's not a metal. It's a non-metal. That means this is a molecular compound, and we follow the prefix naming rules. If your first name's a multiple, you got to use a prefix. So this is going to be called dinitrogen, and then 5 oxygens, dinitrogen pentoxide. Of course, it's molecular. Sodium hydrogen sulfate, which is ionic, number 16, and then dinitrogen pentoxide, which is molecular. Oh, it's got a question mark. Molecular question mark? Yes. That's a random question mark in there. Okay. Who or what or who are the Hunkelbrief twins? I talked about this before. Hunkelbrief twins. And then write the formulas for any 2 acids and any 2 bases. The Hunkelbrief twins, of course, are the diatomic elements. Hunkelbrief reminds you of H for H2, O2, N2, Cl2, Br2, I2, and F2. they all have this diatomic formula. They are molecules, but they're not compounds. They're diatomic molecular elements. Now, acids and bases, you can pick anything you want. Doesn't matter. Go to table K for the acids and L for the bases. They're there. Just make sure you remember K and L. You got a whole bunch of acids and bases just laying around waiting for you to touch. Put your finger in a box and you can have them. What are all the phosphorus and the chlorine compounds? Remember we did this for hydrogen and oxygen and carbon and oxygen and then even nitrogen and oxygen? You got to make the T-chart. Let me get my pen going here. Draw. You're going to make a chart like this on this side. And you're going to put the P over here, and you're going to put the Cl over here. You're going to get out your periodic table. You're going to write these numbers down. Phosphorus, -3. Phosphorus also has a +3 and a +5. Are these the ion charges? No, these are called selected oxidation states. They're just a positive, negative number system that scientists have developed to help you figure out what is possible for phosphorus and chlorine. Now, chlorine has 4 oxidation states, negative, +1. Uh-oh, there's so many. What are we going to do? What are we going to do? Oh, my goodness. It's a good thing I'm in a good mood and you're in a good mood so we can do this. Could you imagine if we were not in a good mood? We would be grumpy right now. The most important thing is we have to be methodical. That's all, just methodical. And with all these numbers, there's going to be some repeats. We don't have to do the repeat ones either. Don't worry, there's not too many. -3 and -1. Skip. Not going to even write anything because I don't want to put too much on here. But -3 and +1. The first one we're going to have is going to be in a 1-to-3 ratio. Right? If we have a -3, we need 3 positives. That's going to be PCl3. That's the first one. Now, with negative and positive, this actually is going to be in a 5-to-3 ratio. Now, how did I know that? I kind of switched them, right? If I have 5 -3s, that gives me -15. And if I have 3 +5s, it gives me +15. So this is going to be something with the formula P5 Cl3. This is the second one. And then if we do 3 negative and 7 positive, it's going to be in a 7-to-3 ratio, or P7Cl3. Next, 3 and -1. Now, if we do 3 and -1, that's going to be in a 1-to-3 ratio again, right? I'm just going to show you. We'll do this. 3 and -1. This is in a 1-to-3 ratio again. We have that one on top, so I'll just put a check. We got that one. Now, does the +3 and the +1 ever sum to 0? Positive and positive? No. Skip. 3 and 5 are both positive. Skip. +3, +7, skip. We're done with them. Now we got to go to the +5. +5 and -1. Ooh, we got to get a new one here. That's going to be in a 1-to-5 ratio. That's going to be PCl5. Oh, we saw that before in the slideshow, right? With PCl3 on top, and now we got PCl5. What about +5 and +1? Skip. +5 and -5. Positive and positive, I mean, no. Skip. And positive and positive, skip. So there we go. There's only 4. There's only 4. So I'm going to wipe out this drawing business, and I'm going to show you what it looks like. Those are all the numbers. And when we put them together, these are what we have. And these are the names. PCl3, phosphorus trichloride. P5Cl3, that's 5 phosphorus, pentaphosphorus trichloride. Then we have 7 heptaphosphorus trichloride. Then we got PCl3 again, which is still phosphorus trichloride, but we don't even need to do that one. And PCl5, phosphorus pentachloride. In our class, there's only 4 possible phosphorus chlorine compounds, and this is what they are. We use the selected oxidation states to help us select the possible positive-negative combinations to make us understand what the formulas are. And once we have the formulas, we use the simple naming rules. Say the name of the atom, unless it's a multiple, then you need a prefix. And the name of the second part always gets a prefix. You knew that. All right. We're going to go through these, and you have to say fake. Fake is a funny word now because there's a lot of fake news out, but I'm not teasing politically. Are they wrong? Why are they wrong? So first one up, chromium, Roman numeral 4 sulfide. Can chromium, Roman numeral 4 sulfide exist? Let's look. Here's chromium. Does chromium make a Roman numeral 4 positive 4 cation? And guess what? It does not. It can't be right because chromium doesn't make it. It makes a positive 2 or a positive 3 or a positive 6. Zinc, Roman numeral 2 oxide. Let's take a peek at that. Zinc's number 30. See it? Number 30. Does zinc make a positive 2 ion? Yes, it does. But does it make other ions? No. So for zinc, it does make a positive 2 ion, but we never use a Roman numeral for zinc because it only makes zinc oxide, ZNO, in a 1-to-1 ratio. We don't use a Roman numeral because it only makes one kind of ion, which happens to be positive 2. Carbon pentoxide. Carbon, let's see, C and O5. Carbon pentoxide. Quick, get the carbon pentoxide antidote. We did this yesterday, or we did this in the last Zoom. C and O only make 2 compounds, carbon monoxide, carbon dioxide. This can never work because with 5 oxygens, that would give this side a -10 oxidation state, right? There's 5 negative 2s. The question would be then, does carbon make a positive 10 oxidation state? Does it? Look. Does carbon have a positive 10? No, of course it doesn't. This is a wacko. Argon monofluoride, ARF. ARF. That's like a dog bark. ARF. Argon monofluoride. What kind of element is argon? I was going to tell you a good joke about the noble gases, but they are gone. All the good jokes, I can't even tell jokes. All the good jokes are gone. Argon is a noble gas. Never makes a compound. Look at this. These are all fake. Fake. All right, this one, I don't know why it's on 2 lines. I'm going to have to fix that, I guess. Hydrogen monochloride. Hydrogen monochloride. How would that look? Hydrogen Cl. That's a good one. Thumbs up. HCl is a molecular compound. You put it in water, it turns into acid. Tin, Roman numeral 4 fluoride. What the heck? Tin is SN, element number 50. There was a time when I was a teacher here, I was going to be 50 years old. That was a long time ago. I'm not going to be 50. Tin, does tin make a positive 4 ion? Of course it does. Tin positive 4, F negative 1. That'd be SNF4. You bet your booties. There's a fun old expression. All right, mercury, favorite element, number 80. Here it is. Mercury makes positive 1 and a positive 2. Can mercury make mercury Roman numeral 2 bromide? Sure. HgBr2. Bing, bing, bing. We get another good one. Look at this. We're on a roll. Niobium, Roman numeral 2 iodide. Niobium is Nb. See it? Niobium only makes a positive 3 and a positive 5 ion. Does not make a positive 2 ion. Sure looks good when I type it like that, but it's not real. Niobium makes 2 positive cations, not positive 2. Bromine lithium. Oh my goodness gracious. Let me move this something out of the way so I can see better. Bromine lithium. That's bromine and lithium. Can lithium and bromine bond together? Sure. Bromine's a negative ion, -1. Lithium's a positive, 1-to-1. But would we ever say the nonmetal first and the metal cation second? No, not in our universe. Maybe in the bizarro world. Lithium bromide's real, but bromium lithium is bizarro world. You're living in the mirror world. It's like a Twilight Zone or something. Okay, MgBr3, magnesium bromide. Looks really good. I can taste it on my mouth. It tastes so good, right? No. Magnesium makes a positive 2 ion. Bromine's a -1. Magnesium bromide is MgBr2. I hope you got these all right. I do. And if not, I hope you appreciate, I hope you appreciate, how you learn, right? You have to make mistakes. You have to make mistakes to learn. You have to write stuff down to learn. If you just do it in your head, you're being lazy. You're not learning, you're being lazy, unless you're a genius, but you're not. I mean, you might be, but you're probably not. Now, see the green one there, tin Roman numeral fluoride, SNF4? That's in toothpaste, right? Tin, yeah. Put that in stannous fluoride. Okay. What is this? This is the old slideshow, due Thursday. And we're not having a celebration Friday. All right? This is just review. We're done. All right, there's going to be 3 more slideshows, 3 more Zooms with a lot of compound naming, formulas to names, names to formulas, transitionals, moleculars, ionic, not ionic, a lot of different stuff. Practice, practice, practice. You also have that review lab. Do the review lab soon. We have a celebration next Wednesday. It's actually Wednesday morning right now. Wednesday morning at, well, is a song, Wednesday morning at 5 o'clock as the day begins. That's the Beatles. She's Leaving Home. It's on Sgt. Pepper's album. There's a good song for everything. We're having a celebration. Don't read this slide. Our celebration is next Wednesday. Look at our calendar. I have to change these slides every year in the classroom because the days of the week change, fire drills, snow days, things like that. But now we got pandemic time and we're not celebrating Friday, but that is a pretty font. I like that font. I think it's called Ink Free. I like that font. I miss you. I wish you were with me. This could be more fun if we do this stuff in class and we tease each other, right? I get to put my hand on your shoulder. You get to make smirky faces at me and I can see your faces. I know when you're happy. I know when you're laughing. This is going to pass. We're going to be together again, right? Even if it takes till next September, right? And it might. We might be freaking stuck at home through June. This is a short part of your life. Right? It's a shorter part of my life because I'm older, and by percentage, it's a much smaller percentage, but it's just as long, right? And I miss you more than you miss me. I really do. And hang in there. If you need help, you need to call me. I can't read your mind. If you're in class, I could see it, but I can't even see you. You hide behind your names on the Zoom. And even if you're in here, you hide behind your mask. I can't see who needs help. And a lot of you probably do need help. And I could help you, right? I could help you with your class. I could help you with your other classes. I could just give you a pep talk, all right? Let me help. I'll be your teacher. You call me if you need me. You know my phone number. Thank you for watching this yet another freaking video. See ya.